Welcome to Asim Code. If you want more coding fun, hit like, subscribe, and let's get started on the next tutorial. Standard deviation is a measure of the amount of variation or dispersion in a set of values. In simpler terms, it tells us how spread out the numbers are from the average, mean, of a dataset. If the standard deviation is low, the values are closer to the mean. If the standard deviation is high, the values are more spread out from the mean. Example: let's say you are measuring the height of students in a classroom. If everyone in the class is about the same height, the standard deviation is low. If there are some very tall students and some very short ones, the standard deviation is high. This Python program calculates the standard deviation of a dataset. Standard deviation tells us how spread out the values in a dataset are from the mean. A small standard deviation means the values are close to the mean, while a large standard deviation means the values are spread out. Calculate the mean of the dataset. The mean is the sum of all values divided by the number of values in the dataset. The mean helps in determining the center of the data distribution. We store it in the variable mean so we can use it in the next step. Sum data adds up all the values in the dataset. Len data gives the number of values in the dataset. By dividing the sum by the length of the dataset, we calculate the mean average. Calculate the squared differences from the mean. To see how much each number in the dataset deviates from the mean, we subtract the mean from each value, and then square the result. Squaring ensures that negative differences are treated equally to positive ones. The list comprehension creates a list of these squared differences. X-mean calculates the difference between each value x and the mean. X-mean 2 squares the difference to eliminate negative signs. The list comprehension iterates over every element in data, applies the operation, and stores the results in squared_if. Calculate the variance. The variance is the average of the squared differences. It tells us how spread out the values are in the dataset. We compute it by summing up all the squared differences and dividing by the number of values. Variance gives an idea of the spread of the dataset, but it is not in the same unit as the original data. Sum, squared underscore diff, adds up all the squared differences from the list squared underscore diff. Len data gives the number of values in the original dataset, which is used as the divisor. Dividing the total squared differences by the number of values gives the variance. Calculate the standard deviation. The standard deviation is the square root of the variance. It brings the unit back to the same unit as the original dataset, making it easier to interpret. A high standard deviation indicates that the data points are spread out, while a low standard deviation suggests they are clustered around the mean. Variance 0.5 calculates the square root of the variance. This step gives us the standard deviation, which is more interpretable compared to variance, as it is in the same unit as the original data. Return the computed standard deviation. Example usage of the function. This is a sample dataset of numbers. A simple dataset with values from 1 to 10. Call the function to calculate the standard deviation of the dataset. We pass the data list to the function as an argument, and store the result in result. Output the result to the user. The print statement displays the calculated standard deviation to the user. Now run our code. I appreciate you watching. Be sure to like and subscribe if you want more content.